Let us now talk about Linkedlist. Linkedlist implements the list interface, but in addition to that, it also implements the deck interface, which is why there should be a broken arrow pointing from Linkedlist to deck. Let's look at the structure of Linkedlist. This is what a Linkedlist usually looks like. Each element is stored in its own object. So this whole thing is called a node, and this node is an object, and our elements are stored inside the nodes. So let's say we have 4 elements in our group of objects. We have object 1, object 2, object 3, and object 4. And this is how they would be stored in a linked list. They would be stored in their individual nodes. So this is the first node, the second node, the third node, and the fourth node. Each node has 2 parts. In one part, it stores the object. In the other part, it stores the address of the next node. So this address is basically the address of this whole node. So if we want to traverse through our collection, what we do is that we start at the head. Again, the first node is called the head. So we start from the head node and follow the address to the next node. Again, if we want to go to the next node, we follow the address to the next node. And that is how we iterate or traverse through our collection. You would notice that this can only move in one direction. What if we are here in the third node? If we are here, we can go forward because we have the address to the next node. But what if we want to go back? We are not able to do that in a linked list. This is why this is called a singly linked list. This is because the nodes have single links to the next node. However, the linked list in our collections framework in Java is not a singly linked list. The linked list implementation in our collections framework in Java is a doubly linked list. This is because in the linked list implementation in Java, we not only have the address of the next node, but we also have the address of the previous node in each node. And this is what it looks like. Instead of having 2 parts for every node, we now have 3 different parts for each node. One part is where it stores our element. One part is where it stores the address of the next node, and a third part where it stores the address of the previous node. So it doesn't matter where we are now, we can traverse backwards as well as forwards. And this is the implementation that is there in our collections framework in Java for linked list. Notice that at the very end, the address is null. That is because we do not have any more elements connected to our linked list. This part of the head node would always be null because the head is the very beginning of the linked list. So this part of the head node would not point to any previous node. If we want to add a new element to our linked list, we would create another node just like this and change this address to the address of the next node. The next node will have the previous address as the address of this node, and this last node now will have null as the address of the next node. Because the linked list in Java is a doubly linked list and it implements the list interface as well as the deck interface, it has all the methods that we've seen in list as well as all the methods that we've seen in deck and queue. So you can use this linked list implementation by using the methods that we have seen in the deck and the queue video, as well as most of the methods that we've seen in the list interface video. One important thing to understand is that list can index through the elements in a collection. And in linked list, we can also have indices. But if you want to access a particular index, what would happen internally is that the linked list would be traversed starting from the head node or the tail node. So here, the index of the first node would be 0, index of the second node would be 1, this would be 2, and this would be 3. Now, if we want to access this index, this list will be traversed from the direction in which it is closest. So index 2 is closest from the tail. So the program would first come here and then use the previous address to come here and then access this element. So the only way to access linked list elements is to traverse through the list one by one. And apart from that, the different methods that we use on linked lists are add, remove, replace, clear, and all the other methods that we've seen that allow us to manipulate collections of objects in lists and queues. So this should be enough for understanding linked lists for now. Let's move on to sets.